Welcome to The Explainer. Today, we're going to pull back the curtain on the unseen shields and, really, the invisible guardians that stand between a factory worker and a potentially lethal jolt of electricity.
Okay, let's dive right in. This image says it all, right? The very same power that runs a factory can just as easily stop a human heart. So how in the world do we keep people safe? Well, the key isn't one single perfect solution. It's all about having multiple layers of defense. Think of it like stacking slices of Swiss cheese. Yeah, each slice might have a hole in it, but if you stack enough of them, something is there to catch a failure.
So first, let's talk about the hazard itself. Electricity is this silent partner in everything we make. And the accidents, they're often caused by these hidden dangers. A little bit of equipment leakage, a simple mistake during operation, or maybe improper maintenance. And that's exactly why a systematic, layered approach is the only way you can even hope to get to zero accidents.
So, where do we start? Well, our very first line of defense is built right into the hardware. The protection literally starts with the machines themselves, because they are engineered from the ground up to fail safely and protect people automatically. Let's see how that works.
This right here is your first line of automated defense, the leakage circuit breaker. You can think of it like a super fast guardian angel for the whole circuit. It's just constantly watching, and it can sense the exact moment electricity goes somewhere it's not supposed to. Now, don't get bogged down by the labels on this diagram, just focus on the main idea. See, under normal conditions, the electricity going out, that's I1, is perfectly balanced by the electricity coming back, I2. But if there's a fault, a leak, suddenly that balance is broken. The ELCB detects that tiny imbalance instantly and bam, shuts everything down in milliseconds. We're talking way before a person could even be seriously harmed. But what if a fault happens anyway? You have to give that dangerous electricity a safe, easy way out, a path away from people. And that, in a nutshell, is the entire job of grounding. And for grounding to work, that escape path has to have incredibly low resistance. Why? Well, because electricity is kind of lazy. It always follows the path of least resistance. So regulations say a grounding system has to be below 100 ohms, sometimes even below 50. This pretty much guarantees that many stray electricity would much rather rush safely into the earth than try to take the tough, high-resistance path through a person.
Okay, so even with the safest hardware on the planet, you still have the human factor. That's a major variable. And this brings us to our second big line of defense, safe procedures. Having standardized rules for how people interact with machines is absolutely critical. And the absolute cornerstone of all safe procedures is something called lockout-tagout, or LOTO. It means before anyone can do maintenance, they have to make sure that machine physically cannot be turned on by accident. And this isn't a suggestion, it's a non-negotiable, life-saving protocol.
And this just lays it out perfectly. It's so much more than just flipping a switch. First, a worker physically locks the power switch with their own personal lock, one that only they have the key for. Then, they add a tag so everyone knows who's working on it. And, what might be the most crucial step of all, they have to test and verify that there is zero energy left in that machine before they ever lay a hand on it. All right, so we've got smart hardware and we've got strict procedures. Our third layer of defense is the people themselves, or more specifically, the protective gear they wear. This is that personal last line of defense, designed to insulate them from any stray current that might somehow get past all the other layers.
And this gear, this personal protective equipment, or PPE, it is not optional. Every single piece serves a critical purpose. Insulated gloves and shoes, they can stop a current from even passing through your body. But that face shield, that's not just for splashes. It protects from something called an arc flash, which is a terrifying high-energy electrical explosion, so violent it can literally vaporize metal in an instant.
But what happens if, despite all of these layers, an accident still occurs? A clear, well-rehearsed emergency plan is the absolute final safety net. And how you react in those first few seconds, that can be the difference between life and death.
In an emergency, this sequence is totally non-negotiable. The first, most important rule, you never touch the victim until you are 100% certain the power is off. Your first action always has to be cutting the power source. Everything else comes after that.
So, as we've seen, no single gadget or one rule is ever enough. Real electrical safety is a complete system. It's where the hardware, like circuit breakers and grounding, and the procedures, like lockout-tagout, and protected people all work together to create these multiple barriers against danger.
This slogan from the source material just summarizes the whole philosophy perfectly.
It's a really powerful reminder of the two most critical principles we've talked about: the sequence of emergency action, power first, then people, and the absolute necessity of the lockout-tagout procedure.
You know, this kind of systematic thinking isn't just for factories. It's everywhere. It's in the circuit breakers in our homes, the airbags in our cars, all the redundant systems in our infrastructure. The big takeaway here is that true safety is almost never about one brilliant feature. It's almost always designed in layers, creating this unseen shield that protects us every single day.